Okay, we do have a lot of people on quarantine. That's something we need to be ready for, okay? You guys all know where to get my stuff. Hopefully everyone at home knows. My computer just shut off again. I was hoping it would. Alright, okay, so we're gonna look at me. This is called a book. I haven't opened up this book in like 3 years. It's heavy, good weightlifting. Alright, here we go. Copy down this table. Actually, you want to know what? I'm going to do it like this. Title it Graphic Systems of Equations. I'm going to bring out my book. Scoot it right up here. I want this table copied down inside your journal. Clear up, clear up, clear up. Oh, yeah. Okay, there we go. I want everything, the graphs, terminology, solutions, everything. These are called possible solutions, I think. Veronica, you may need to come over here so you can see better. You might say I'm a dreamer. You might say, should have done this update at home, but it just forced it on me today. Right in the middle of second hour. Okay. These are called possible. So today, all of chapter 6 boils down to, we're going to be playing in the world of two equations. And we have to be able to do two equations in order to do the problems. So the very first thing they start us off with is graphing. Now this is something most of us should be pretty familiar with. We've graphed all of chapter 3 and all of chapter 4. So we're going to dive into this a little bit today. You guys all have that in front of you, so I'm going to take this thing away to kind of start getting set up here. The most important thing you have to know is the number of solutions. So one of the really cool things is if lines cross, so if there's two different equations and they cross like that, there's going to be one solution And is it independent or dependent? It's independent. The reason why it's called independent is because it's basically one solution. And then is it consistent or inconsistent? It's consistent. Now look there. If you guys look at your table, the next one, how many lines are right there? One. Now look, there is technically two there. We just can't see the other one. Where's the other one at? It's in the exact same line. So you can have different equations that create the exact same line, right? It doesn't matter. The only thing is, if it's the exact same line, there's an infinite number of solutions because they cross an infinite number of times, right? If it's the exact same line, they're going to cross an infinite number of times. Now this one's dependent. The reason why it's dependent is because they're the same line, and it's also consistent. Notice there, the ones that actually have solutions are consistent. The ones that do not have lines, the ones that do not cross, which are what type of lines? Parallel, are inconsistent, or they have no solutions. The reason why they have no solutions, they never cross. Okay? Any questions so far on any of that? So if they cross as one solution, if it's the same line, it's an infinite number of solutions. If it is parallel lines, then it is no solution. Okay. What do we look at to determine if lines are parallel? Okay, that's it. But what about if they don't tell us? What about if they just give us graphs? The slope tells us if lines are parallel. How do we know based upon the slope if lines are parallel? If they have the same slope, then they are parallel lines, right? Or infinitely crossing, they'd have to be the same line, right? Okay, good. As soon as this thing here, I'm going to go over here. I'm just going to look and see kind of what they asked for you on your homework. Because I think I'm actually not going to spend too heck of a lot of time teaching this because, one, you guys already know how to graph. I'm not going to teach you again how to graph. This is something you guys have actually become pretty good at. Well, most of us. There is some that aren't too hot yet, and I guess this will be good practice for you. But I don't see the need in teaching you how to graph. The only difference is that right there. You have to be able to identify if it crosses, it has a solution, right? It has one solution. If it doesn't cross, no solution. If it's the same line, it's an infinite number of solutions. Then, of course, consistent. But all that's inside of your journal right now. So let me just look at your Alex homework real quick and just determine what we need to do. Give me just a sec. Okay, oh boy. Okay. Yep, I'm going to give you your homework. Okay, will you go push stop up there, Brendan? Yep.